Hey guys, this is Samir from Machine Learning TV, and this is a video from programming series. As you know, knowing how to solve problem in an optimal solution can be critical for data scientists. This is why I decided to publish these weekly videos. In each video, we will go through one of the Leetcode problems and we will try to solve it together. So today we are going to talk about the maximum subarray problem. It is very interesting. So let's see how we can solve it. So what this problem is about? Imagine that you have an array with numerical values, and these values can be negative or positive, and here we have our constraints. The problem that we are trying to solve is to find a subarray with contiguous elements which result in the highest possible sum. So let's, for example, take these two elements, minus 2 and 1. What is their sum? It is minus 1. But what if I choose these two elements? The result will be 3. It is already higher than my previous results. Therefore, this subarray is much closer to my optimal solution than our previous subarray. As you can see, in the case of this array, the subarray which results in the highest sum is 4, minus 1, 2, and plus 1. There is another example which the array itself is the subarray with maximal sum. So let's see how we can solve this problem. One possible solution, which isn't the best solution, is just simply start from this element, then take into the account the next element, then the next, and in each step we calculate the sum and we save our results. When we reach to the end of this array, we start from the next element, then calculate its sum with the next, and with the next. We save all of these results, and in the end we take the maximum and we will have our output. However, this isn't the best algorithm, and let's see if we can do better. To explain this, the optimal solution a little bit better, I created a note. So let's see how we can solve this problem through a faster solution. So I think it is important to understand what is exactly that we are trying to solve here. So this problem is a problem of expansion. It means that in each step we need to decide whether we are going to expand our subarray or not. So always we start from the first element, and our first supposition is that this first element is the subarray with maximal sum. It is minus 2. Then we need to decide whether we are going to expand this subarray or not. In every step, we need to keep track of two things. The first thing is something that I name it as expansion sum. And the second thing is the global sum. So what are these two things? I will explain them in a second. So imagine that we are here. Up until this element, my expansion sum is minus 2. Expansion sum is the sum of all the elements in the subarray that I have been expanding. And the global sum is the subarray with the maximal sum. So in the first element, my global sum, I'll call it GS, is minus 2, and my ES is also minus 2. So I need to decide if I'm going to expand it or not. If I expand this array, what will be my result? My result will be minus 1. So here I need to decide whether I want to expand my subarray or not. And how I can decide by just seeing this element. If I expand, my sum will result in minus 1. But if I don't expand, I can have a new beginning from this element. If I start from this element, my sum is already higher than minus 1. Because it's a positive number, if I continue from this element, I will always have a better result. So this is my condition. I always need to choose between the previous sum of all of my previous elements and this element. If this element is bigger than all the previous elements, then I need to have a new start, and I will just record the previous sum, and I will continue my exploration inside this array. So now I am in this element 1. What is my expansion sum? It will be 1. What is my global sum? Well, it is higher than minus 2. It is also higher than minus 1. Therefore, I will update my global sum. So what will happen if I expand this? If I expand this array, the result will be minus 2. Minus 2 is already better than minus 3. Although it won't update the global sum, but it is already better than minus 3. So if I wanted to start from minus 3, I would have a sum with lower number, with a lower result. So I will expand. So here my expansion sum will be minus 2, and my global sum will continue to be plus 1. So if I want to expand this with this new element, the result will be plus 2. If I start from here, I already have a subarray with better sum. Therefore, I will update my expansion sum, which is 4, because I am having a new start, and the global sum also will be plus 4. Why we will update the global sum? Because it is higher than my previous global sum, which was plus 1. Okay, but what will happen if I start from here and expand it? If I start from here and expand it, the result will be plus 3. Plus 3 is already higher than minus 1. It is not higher than my global sum. Therefore, I won't update my global sum. However, I will update the expansion sum, which is plus 3. Okay, so what will happen if I take this plus 3, which is the result of the previous sum, and I sum with 2? In other words, I'm expanding again. The result will be plus 5. It is already higher than 2. It is also higher than my previous global sum. Then my expansion sum is 5. My global sum is also 5. So I will keep expanding until I reach the point where it doesn't make sense to expand more. So I'm expanding again. The result will be plus 6. It is already higher than plus 1. it is also higher than my global sum, then I will expand and update. And what will happen if I come here? If I expand here, the result will be +1. It is already higher than -5. Then I will keep expanding. However, I won't update my global sum. Then expansion sum will be +1 and global sum will be +6. And if I expand again, I will have +5 as my expansion sum, +6 as my global sum. And in the end, I will return my global sum as my output. Okay, great. Now let's solve the problem. As I said, we consider that the first element is our global sum. Then we iterate through our array. We start from the second element because we already considered that the first element is our global sum, and through our iterations we are going to update it. So what about our expansion sum? We can keep track of our expansion sum, or we can update the array itself, and this way we don't need to save our results in another array, and this way our space complexity will be lower. So let's do the updating. So plus. Right. This is where the expansion happens, and this part is where we are deciding that whether we are going to expand or not. Now let's update our global sum. It will be the nums I, which is my new expansion sum, and the global sum itself, and then return the global sum. Let's go through some test cases and see if it will pass. Great. Now let's just reduce the number of elements and see if the function passes. Great. Let's take this array and test it. Great. So I think we are ready to submit. Let's see what will happen. Okay, great. As you can see, our memory usage is better than 97%. And here, with some changes, we can improve this number as well. I think it is very important to mention that the algorithm is already optimized, but we can do some tricks to make it a little bit faster. For example, here, each time we are accessing our elements in the array again and again, just by saving this value in a variable, I think we will have a function which is a little bit faster. And that's it. Thank you guys, and until the next time that we will go through another Leetcode problem. Thank you.